Welcome back to session 3, electrical power. What we're going to do now is we're going to wire up another simple series circuit, power supply, fuse, switch, ammeter, resistor and the voltmeter in parallel. The resistor is going to be our load. This particular practical exercise we're going to have a look at how power relates to voltage and current. So let's wire it up. So we've got the power supply into the fuse. From the fuse, I think we've been using black, yep, into the positive of the ammeter. From the ammeter, in fact we'll go red. So into the red of the ammeter, from the ammeter, negative of the ammeter, okay, into the resistor. In this particular case I've got a 10 ohm 25 watt resistor, okay. So into there, and from the other side of the resistor back to home or the negative of the power supply. The voltmeter goes in parallel across that load. So positive of the voltmeter across the positive of the load, it's positive there, and negative back to the negative of the power supply. Okay, so that's my Prac wired. Let's have a look. Obviously you've got a risk assessment here to carry out. Okay, so the voltage levels as per the diagram, we're going to do 5 and 10 for the purpose of the exercise. So looking at the Ohm's law triangle, so the V, I, R, and we've also got the power triangle, P, V, I. So the relationship between these two, as we've discussed previously or in your course notes, power. If you've got resistance, you can also work out the power. If you've got the current, you can also work out the power and the voltage. So P is equal to V times I. P is also equal to V squared divided by R, okay, which is a combination of substituting VI into the I, and P is equal to I squared R, another combination of substituting the I into here. Okay. So if we have our power supply at 10 volts, that's our power supply, and we've got a resistor of 10 ohms. So power supply at 10 volts, resistor at 10 ohms. What are we going to use for power? Well, we've got voltage and we've got resistance. So this particular equation here gives us voltage and resistance, and there's power there. So we'll use this particular formula right here. This is on your formula sheets or equation data sheets that you'll be given. P is equal to V squared on R. So if I substitute that in, P is equal to V squared, so 10 squared divided by 10 ohms is equal to 100 divided by 10 is equal to 10 watts. So if I was to feed in 10 volts from this power supply, I'd expect to see a wattage of 10 watts. And that would be safe because this resistor is a 25 volt resistor. What would happen if I was to halve this voltage? So instead of having 10 volts as a supply, what would happen if I, say, change the supply to 5 volts? Well, we started there. Supply is equal to 5 volts. A resistor is still a 10 ohm resistor. P is equal to 5 squared divided by 10, which is equal to 25 divided by 10, which is equal to 2.5 watts. So we have two equations. What I've done, I've gone 10 volts, I've halved the voltage. What has actually happened to the wattage? It's gone from 10 watts down to 2.5 watts. So the wattage is decreased by 4 times. Or if I started at 5 volts and jumped up to 10, so double the voltage, you can see my wattage has changed by 4, quadrupled. Let's check these theories out. Okay, and the other thing we've got to assume as well, using Ohm's law, I is equal to V on R, we'll check that as well. I is equal to V on R, which is equal to 10 divided by 10, which is equal to 1 amp. That's the current. So we want to make sure that the current is 1 amp. And this one here, I is equal to V on R, which is equal to 5 divided by 10, which is equal to 0.5 of an amp. Okay, so we've got an M meter here, which we can measure the current, and we've got the voltmeter here. Okay, and we can do the calculation on power. So, one thing I haven't wired in, which we've forgotten, excellent, those that have picked it up, is the switch, probably most important. So we'll refer back to our circuit diagram there and see where did we go wrong. You can see there's a switch. So I've jumped from the fuse into the M meter, forgot the switch. Probably a pretty important part there, so let me put the switch back into play. So it goes from there to the switch, output of the switch, into the M meter. Switch is off. Okay, so we'll turn that on, we'll turn the meters on, turn this, we'll start with the one at 5 volts. The other thing which I can show you as well, the idea of this practical exercise is to feel the temperature change or feel the power. Power being the rate at which energy is used, the rate of work being done. So because obviously it's a video presentation, what I've brought into play here is a digital thermometer. So if I zero that in onto that resistor, we can see the resistor now is at 23 degrees, which is pretty much the standard temperature of that bench there, 23 degrees. So when I add power to the circuit and turn it up to 5 volts and turn the switch on, 5 volts, turn the switch on, we've got half an amp, 0.5 of an amp, and we've got no voltage whatsoever because I didn't wire them properly, clearly. So, try again. Okay, so negative of the voltmeter goes to that side of the resistor. Okay, so temperature now on the resistor with half an amp going through it, it's increased up to 25, 26 degrees. Change up there. So temperature's actually increased about 3 degrees, and feeling that, starting to get a little bit warmer. Now if I increase the power from 5 volts, 2.5 watts, up to 10 volts, goes up to 10 watts. So let me try that. Goes up to 10 volts. The current's increased to 1 amp, or thereabouts, almost at 10 volts. And let's have a look at the temperature on that resistor now. Now you can see the temperature has increased significantly. It's gone from 23 degrees up to 33 degrees. 36, 37. Then keeping in mind it's now 10 watts, and I feel that resistor, and that's got quite warm to touch. So on and so forth. So I'll turn that off. The other thing I'll do, I'll introduce a different wattage resistor. So here we've got a half watt resistor. So using the same calculations again, the same voltage. This here is a 10 ohm resistor. It's a half watt. This was a 10 ohm 25 watt resistor, and that one got quite warm. What is going to happen when I turn this power supply on? What is going to happen to this half watt resistor? Obviously the temperature will increase, we know that, so we've done that. I suspect we're going to have some serious issues with this resistor, being it's rated at half a watt and we're about to expend 10 watts through it. So quite a bit of power is about to flow through the resistor. Let's have a look, let's see if we can screen grab this. So I'll turn the power supply on first, so it's 10 volts, and I'll flick it on and see if you can see the resistor, the current and the voltage. There we can see that the resistor has smoked. So for the same amount of current and voltage, that resistor smoked straight away. So once again, we've got to be very aware that as we increase the voltage, it has an exponential effect on the power dissipated by the component. Luckily you can't smell that. Acrid smell. Now we'll go back to one other part of this practical exercise, which is the last part of it. We had a look at a watt meter, which is right there. So the other part of this practical is to get an actual instrument that measures current, voltage and watts, which is this one here. So this particular meter, okay, we'll put it as per the circuit, the ammeter, voltage there. So it measures voltage, current and watts. So it can actually tell you the actual wattage that the power is being used in the circuit by the meter. So we'll wire that up. So the amp meter here goes into the watt meter. Wrong one. The amp meter goes into the watt meter from there, and your facilitator will show you how to wire this up in class. From the output, there's connections at the back of this here, just like a little amp meter. Goes from there back into the load. So from there back into the load. Put it around the right way, so it's into the load. Voltmeter goes across it. And the other connection from the watt meter, it goes from here back to home, back to there, as per this here. So you've got the watt meter has a M and L, mains and load, which is like an M meter and a voltmeter built in. So V1 connects to the mains and V2 goes back to the reference point of the circuit. So turning this meter on, we should read, I've still got the voltage on 10 volts, so we should read 10 watts. Okay, as per our calculation. Let me just have a look here. So 10 volts, so we should read 10 watts, 1 amp at 10 volts. Let's have a look. So here we have, I'm not sure where that leads in the road there, but here we have 10 volts, almost at 1 amp, 0.997 of an amp, and 9.9 watts. As we can see, this meter does all the readings in one, so thus replacing this M meter and the voltmeter. Turn them off. And that concludes this power experiment.